Hey, today we're going to talk about graphing lines from their slope-intercept forms. Before I say anything else though, I'd like to make a request. I know math is intimidating. I'm a math person whose brain isn't math-oriented, and it takes me a ton of time and effort to understand new concepts. And I often get discouraged with things when I lose track of why I enjoy math in the first place, which is I love the puzzle of it all, the game within the process, knowing what I have and where I need to go, and experimenting, sometimes more than once, with the process until I can get where I want to be. So my ask is this: just for the next couple minutes, try to think of this as a game, to find the hidden objects, organize the blocks correctly, picking up on the little details, so try to focus on the process instead of the end result. The only stakes here are your own understanding, so take your time, think, and try to let your mistakes be a sign of growth instead of failure. To start, this does require a basic knowledge of algebra and an understanding of the Cartesian coordinate system. Don't worry if you're a little bit rusty though, because I'll review everything before we jump into our example. So let's start with Cartesian coordinates, which is much simpler and hopefully more intuitive than it sounds. We have two axes, the y-axis and the x-axis. Today we'll be working in positive number land, which looks like this, because I personally am very fond of these bad boys when I'm learning new things. In the scope of all real numbers, the axes look like this, and we are going to be in this quadrant. When you plot a point on these axes, it's written like this, with an x value corresponding to the x-axis and a y value corresponding to the y-axis. X is always first and y is always second. Nice. So now let's look at our slope-intercept form, y equals mx plus b. M is the slope here, which is how steep the line is. Are you walking up a ramp where m is really small, or a cliff where m is really big? The y-intercept, b, is where the line intersects the y-axis. One fun thing we can put in our toolbox for later is that we can turn this intercept into a coordinate pair super easily. If you think about our graph, right, a point on the y-axis can't have a value on the x-axis, which means x has to be 0. And that means that our coordinate pair for b is always 0, b. Hold on to that later as we move on to our example. So our example, the instructions are graph y equals 2x plus 1. Now to graph a line, we really want 2 points that we can connect to make a line. So let's look at how to do that. Step 1 is going to be identifying our slope and our y-intercept, and then turning our intercept into our first point. Here we see that m equals 2 because 2 is the coefficient of x in our equation. We can also see that b is positive 1. Now if you take out that earlier knowledge from 2 seconds ago, we know that our coordinate pair at b will always be 0, b, because you can't move on the x-axis and also be touching the y-axis. So our first point is going to be 0, 1. Step 2 is to figure out our second point. Now there's a few ways to go about this, so I'm going to go over how to do it with a graph and how to do it with algebra. First, quick refresher on slopes. If you want to move between 2 points on a line but can't move diagonally, you're going to have to go up and then over, like stairs. We call this our rise, our change in y, over our run, our change in x. And this is a fraction. Pretty neat, no? So you'll notice that 2, which is m, is not a fraction. Well, we can do a fun little sneaky thing here and say that 2 is also equal to 2 over 1, because anything over 1 is itself. And now we have a rise over a run. So if we do this algebraically, we're going to write down our first point, 0, 1, and then we're going to add our change in x to the x value and our change in y to the y value. So doing that, we get 0 plus 1, 1 plus 2, which equals 1 plus 1, 3. If we look at this on a graph, we draw our axes and label our first point 0, 1, then we rise 2 units from that point and run right 1 unit. We plot where we've landed, and now if we label it, you'll see that that is the point 1, 3. Now in step 3, all we've got to do is connect the 2 points with a line, I've got my computer set up to make straight lines, but as long as your line looks mostly straight, you should be good. We'll label our line y equals 2x plus 1, and we're done. We've solved the puzzle, met our goal, played a game, and we have a process now for when we encounter other problems like this in the future. Thanks for watching. I'll see you later.